Okay, I've been working really hard at getting this tutorial correct. We're talking about advanced firewall ACLs or advanced firewall access lists. And we're going to talk about two in particular. I've already done some tutorials on the TCP established ACL. And so this tutorial is going to focus on reflexive ACLs. And what's the point? Well, with an advanced firewall ACL, I've written right here, the goal is to not open a permanent hole in your firewall from the outside, but to open it only for traffic initiated from within your network, so from within the inside, and only for a limited time. In other words, if you don't have to open a hole in a firewall, let's say located here, here's our network, let's say over here, right? This is our network over here, right? And if we don't have to open up a hole in our firewall permanently, let's say to let port 80 traffic in, right? That would be good. If we could not open any permanent hole in our firewall, that would be good, because why would we need that? Well, we need it if we were running a server, let's say, on our network, and we wanted the public to have access to that server 24/7, like a web server or a mail server or something like that. But you can see on this network right here, we've only got this client, right? So we have a client here, PCs, let's say, and what they need is they need access out. They want to be able to run pings, they need to get to the web, to get to web pages and websites, and they need to get, let's say, email, right? So they need to get out, right? But we don't need to set up holes in our firewall, permanent holes in our firewalls coming in, right? But still, this traffic needs to get back somehow. So what we can do is we could set up, let's say, a reflexive ACL. And right, and a reflexive ACL is a little bit better than a TCP established ACL, because a TCP established ACL, while it's good because it tries to check to see if the traffic has been initiated from within the network, and it does that by checking TCP session fields, like it looks for an ACK bit or a reset bit or a SYN bit, let's say. So TCP bits in the segment fields that would signify that there has been an opened TCP session happening, which would signify that it's been established, let's say, from inside of the network, right? But the way it does it, it just checks these fields. Well, a hacker could maybe set the bits on those fields if they knew what they were doing, and then when the packet came across the network, it would think that it was initiated from the inside, but maybe it wasn't. So a better way to do it would be to use a reflexive ACL. And a reflexive ACL does a little bit more. For one, to check to see if the traffic has been initiated from inside the network, it checks the source and destination IP addresses, it checks the source and destination port numbers, it checks the TCP session fields for ACK bit or a reset bit or SYN bit, and it also, what it'll do is it will also set up a temporary return access list or reflexive access list. We call this an ACE, an access control entry, that will temporarily open a hole in the firewall to allow the return traffic to get through. So with a reflexive ACL, you set it on the inside, right? You set it basically outbound. You could set it here on the outside, but outbound, and then it'll open up a temporary hole for returning inbound, right? So you basically have to set up two ACLs, outbound and inbound. All right, and that inbound will only be opened for a temporary bit of time, so it has to happen only if it's been initiated from within the network, right? So it's only made a temporary hole. If the traffic hasn't started from somebody requesting a web page, right, it's not going to be allowed back through. All right, so and here are the steps that we need to do it. We need to create an outbound named ACL. It needs to be an extended ACL, and we need to create an inbound named ACL that's also an extended ACL, and these ACLs need to have specific keywords in them to make them a reflexive ACL. The outbound needs to have a reflect keyword, and the inbound needs to have the evaluate keyword that's going to evaluate the reflexive access lists. Then we need to apply both the outbound and the inbound ACLs to our interfaces. We could do it on two interfaces, or we could decide to do the whole thing on one interface, and that's what we're going to do here. So another issue is that we cannot do this type of lab in Packet Tracer because the routers here in Packet Tracer do not have the ability to do the reflect or the evaluate commands within the iOS. So we're going to have to do this on in a different scenario, which I'm going to go to in a second. Here's a list of the commands that we're going to use to make this work. We're going to permit ping. We're going to permit, let's say, web traffic, TCP traffic, right, and mail traffic by permitting TCP traffic essentially. And we're also going to permit UDP on port 53 for DNS, right? Because if you're going to get web pages, you're not just going to need IP addresses going out on port 80, but you're also going to need to resolve DNS names. Okay, so what I'm going to do is, to do this lab, I'm going to use NetLab to do it. And what we're going to do is we'll have the same scenario as you see here. We'll have a 1 network over here with host 1.100, and then over here we'll have a 3 network with host 3.100, and then this network right here will be 10.2.2 network, and over here this network will be 10.1.1 network. And what we're going to do is we're going to try to set up a reflexive ACL outbound and inbound on this interface right here on this router right here. Okay, and the interface will actually be on serial 0/0/0, and you'll see it in a moment, and we'll take a little bit of setting up to do, and then we'll see if we can set up this reflexive ACL and get it working. So let's go to the NetLab, and I'll show you the NetLab. Here's the NetLab, and the NetLab has that same setup, and you can see that it's set up with a default configuration that allows us to kind of immediately be able to have communication set up. And there's the 1 network over here. Here's the 3 network over here, and I've set PCA to 1.100, and I've set PCC to 3.100. So you have to give them an IP address to start with. So the first thing I did was give these 2 clients an IP address. So let's see if they can ping across the network. So we'll open them up so you can see them. Here is PCA. I also changed the desktop color to kind of a greenish color so you could tell the difference. And then here's the PCC. So here's 1.100 and this is 3.100. And I had to configure the NIC, right, with the IP addresses. And we'll just open up a command prompt and we'll say ping 192.168.3.100 to see if we have initial communications. And you can see we get a reply, and so it's good. So we can ping across the network, and that's successful. The reason we can do that is because the routers have been set up with a default configuration, right? And let's take a quick look at it. We'll just look at R1, and it'll be pretty revealing. So we'll open up the R1 router, and we'll change the font size to a size that will help you to see it better. So here's the R1 router that we're going to work with, and we'll just do a show run to start with so that we can see the running configuration, right? And it has just a basic configuration. The interfaces have been configured with IP addresses, right? And then instead of static routes, you'll notice that the routing is being handled by EIGRP. Right? So we have EIGRP routing protocol configured, and so these routers are talking to each other using EIGRP and sharing their routes with one another so that we can route across the network. And what we want to do is do a show IP route, and you can see that it has the routes that it's learned from EIGRP. You can see the D's here, and then it has 2 connected routes, so the 2 routes that are connected on its interface, right? So we're going to use this router to write our access lists. But what we need is we want to try to set up a reflexive ACL that will allow us to request web pages from the other side of the network from a web server, right? And then since the request is initiated from the inside, it'll open up a temporary hole in the temporary return hole in the firewall, allowing inbound traffic to go through for a limited time per request. So we're going to set up a reflexive ACL that will work for port 80. Now, to do this, this PC has a bunch of tools on it, but it doesn't seem to have a web server on it. So what we're going to do is we'll use the web server built into R3 as one that we'll test with. So I'm going to open up the R3 router, and we're going to We'll set the preferences here, font size to 18, hit enter. And what I'll do is I'll do conf. To get this to work, I'm going to first of all set the enable secret password, enable secret to the word class, which is typical for the Cisco curriculum, right? Default, enable secret class. And then what we're going to do is we'll say IP HTTP server to activate the web server. All right, so that's working now. So that's all we need to do here, so we'll close that out. And now we can test it out with PCA. So we'll go to PCA, we'll reconnect, we'll open a web browser, and we'll see if it works. We'll say 10.2.2.1, which is the address of the router. We'll hit enter. And you can see that we've connected to 2.2.1. It's asking for a username. There is no usernames right now. It's just admin, the default. So we'll just put in the password class, which is level 15 accessed to get to privileged mode. And we'll hit OK. And you can see we can reach the web interface on the router. So that's good. All right. So that was successful. So we'll close that out. And so we know that we can reach that web server right now. But we can reach the web server because we have no firewalls set up on any of these routers at all. So it's just open communication going back and forth. So now what we'll do is we'll write our access list and we'll see if we can, what happens to communications when we do that.